Welcome to the strange and beautiful world of quantum physics. In this world, particles can exist in many places at once. In this world, reality waits until we observe, and barriers can be crossed without breaking. Basically, quantum physics is a branch of science that describes matter and energy at the smallest scale. But there are a lot of bizarre and strange property in this theory. Let's begin our journey with the first mystery, superposition. I'm going to use this coin to explain it better. In the classical world, if I flip this coin, it's either head or tails. But in quantum world, if this coin is a quantum object, not a classical object, can be heads and tails simultaneously. That's the power of possibilities. It is strange. Yeah, I know. That's why we call it superposition. And that's why we call it quantum object. This first mystery leads us to one of the most famous thought experiments in science, Schrödinger's cat. Schrödinger captures this idea with this story. Imagine a cat sealed in a box, which is connected to a quantum trigger with a 50% chance of releasing the poison. Classical logic says the cat is either dead or alive. But quantum logic says the cat can be dead and alive simultaneously. It is very bizarre and counterintuitive. There are many interpretations in quantum mechanics that try to explain them. One of the most interesting interpretations is the interpretation of multiverse. And it says maybe we only have access to one branch of reality. So there are parallel universes, and in each parallel universe, we have different reality. In one reality, cat lives, but in the other one, it dies. In one reality, coin is head. The other one, coin is head. Okay, interesting. Let's start another strange property. Let's talk about spooky action at a distance, quantum entanglement. This is also another strange property of quantum mechanics. Now I need 2 points. It's the one. Okay. Again, imagine this is spinning point, but this is quantum objects. Remember, when I said it can be simultaneously head or tail, it was not about the lack of knowledge. It was about interesting probabilistic nature of quantum physics. So quantum physics is probabilistic in its nature. Now I have 2 points, which is 2 quantum objects. Now I want to have some experiment. I try to create a combined shared state and try to link them, try to entangle them, and then send one to another part of the universe, light year way away, and then another side of the universe, and then I keep this one here. Okay. The strangeness comes now. When I measure one property of this quantum object, the other quantum objects could be in another galaxy even, instantly, immediately response. And that's why Einstein didn't like this idea and call it the spooky action at a distance. This spooky action is not strange. It's also very powerful. With the help of quantum entanglement and quantum mechanics, we can achieve something remarkable. Quantum teleportation. Yes, we can teleport quantum states from one side of the world to another. We can basically destroy our quantum state here and recreate on the other side of the universe. And it has been demonstrated over the kilometers. on the Earth and even between Earth and the satellite. Okay, let's talk about something else. Let's talk about wave-particle duality. Quantum objects sometimes behave like a particle, sometimes behave like a wave. That's why I call it quantum object. So, in classical world, walls stop us, of course, because we are not basically quantum object. But in classical world, in quantum world, the story is different. In classical world, if I throw this ball, it bounces back. But in quantum world, because sometimes they behave like a wave, if I throw this ball to quantum object, actually, there is a possibility that it can disappear here and reappear on the other side of the wall. And that is the reason that sun and all the stars shines, because inside the core of these stars, quantum tunneling help them for the fusion reaction. Okay. But quantum mechanics is not only about the cold, isolated system in the lab. Some researchers believe that quantum mechanics happens inside a living system, inside us, birds, animals, plants. There are some theory which is called quantum biology that states that counterintuitive quantum mechanical phenomena like superposition, entanglement, and tunneling that I mentioned happening inside living systems, which is very bizarre. By the way, all these quantum mechanics are not only theory or are not only abstract ideas. Through the quantum revolutions, it reshaped the civilization. We already lived through the first quantum revolution. It gave us transistors, semiconductors, all the foundation of modern electronics. Your smartphones, your laptops, your iPad, your MRI machine, CT scan, all of them are the gift of quantum mechanics. And now we are in the second quantum revolution. Quantum sensors provide us extreme precision for measuring objects, quantum communication for unbreakable security, for quantum internet. And last but not least, quantum computing. Quantum computing, for the first time in history, kind of redefining the core of computation with the new paradigm, using the same laws of quantum physics. So the problems that takes millions of years for standard classical computers, can be solved by quantum computer in a few minutes. So I still believe that our understanding of quantum mechanics is far from complete. And there are a lot of truths about the nature yet to be discovered. And hopefully, the future generation of scientists will discover them. Thanks for listening. Until next time, stay tuned, stay quantum.